This is really cool. Here's the part where I tell you I am definitely going to post the slides on my site tonight. In this case, though, there are no slides. The code for today's presentation is up online right now. Head off to github.com/RobRich, minimal APIs ASP.NET. And an easy way to get there, head over to robrich.org, robrich.org, click on minimal APIs, and that will get you straight to the code with GitHub. While we're here on robrich.org, let's click on About Me and see some of the things that I've done recently. I'm a Microsoft MVP and MCT. I've done some other things, like I'm a Cypress ambassador and Redgate ambassador, Docker captain. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver that completed software to charities. If you're in Phoenix, come join us for the next AZ GiveCamp, or if you'd like a GiveCamp here in Salt Lake or wherever you're connecting from, then hit me up on any of the socials or find me here at the user group. You can also send me an email, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, I got to write a few books, Pro Microservices with .NET 6, still applicable to .NET 8 and 9. It's more of an architecture book. That was a lot of fun. I got to do 2 chapters in there. And one of the things I'm particularly proud of, I put a comment on a .NET Rocks show. They read my comment in the art. They sent me a mug. Woo! So that's my claim to fame, my coveted .NET Rocks mug. So let's dig into minimal APIs. What I like about this is there is no slides in this presentation, but we'll wander through each of these folders. And so you can do this as well. Pull them up in GitHub and continue on. Let's first start with a bare minimum project. I have here an empty folder. It has a properties and a site.cs proj. The site.cs proj just says it's .NET 9. Properties just has launch settings that I might need. And we've added a program.cs. Yes, I have the C# plugin inside of VS Code, so it added a few more things too. So here, let's do this. I'm going to say var builder equals web application dot create builder. Thank you, GitHub Copilot. It knows where I'm going. And I'm going to say var app equals builder.build, and I'm going to say app.run. Well, what is it going to do? Let's add one thing. Let's say app.map.get, and I want to map the that home page to, yep, GitHub Copilot knows that I do this demo. Let's say return hello world. Except for I don't want to do that. I want to say, let's return some JSON. New message equals hello world. But, well, maybe I want to make that a little bit more dynamic. So let's actually say hello name. And if you don't pass in a name, then I will return world. So how do I take in a name? Well, let's say this will say string name, and I could add from query if I wanted to, but I'll just leave it alone and let it automatically map it from wherever it is. And there's my program. That's it. So let's start it. I'm going to say .NET run, and let's take a look at this app. It's going to restore some NuGet packages associated with ASP.NET. Since I'm running Teams and I've got a Visual Studio up, and it's going to take it a minute to restore. There we go. And let's launch this website. We automatically got HTTP to HTTPS redirection. Oh, actually, no, we didn't. Let's go to the HTTPS one. There we go. And so we have our message, hello world. And if we wanted to, we could say name equals slc.net. And now we'll say hello slc.net. If we pull up the Chrome developer tools and take a look at the network tab, we can see that we've got request payload. We've got a status code of 200. We've got content type of application JSON. We can see that it's processing query string and resolving that to, we've got kind of a lot going on, and all of that in 4 lines of code. Well, that's pretty cool. Now, the cool part is we just launched an API with pretty much no code. But is this the application that you wrote yesterday or that you're going to write tomorrow? How did we get here? Like, what is this? What is this application? It's just kind of, well, yeah. Let's start back a little bit. We just did this bare minimum. Let's start with an ASP.NET 5 project. And I've opened it up here in Visual Studio, and we'll start it off. Now, this isn't quite the template, but it's pretty close. We have a program.cs, and we have a startup.cs, and we have all the things. Now that we've got our application up, let's take a look at it. So we've got a home page, we've got a privacy page, we've got an about page, we have a weather forecast page, we can also come to this Swagger page and we can execute this, things that we've all seen before. But there's some subtlety here. When we take a look at our home page is a home page controller. Here's this controller. And it's able to render this view. And so if we come in here to views, we can see this home view, and it's outputting the content here in this .NET 5 sample. But if we come over here to the About page, this About page actually works a little bit differently. The About page is a Razor Pages page. Here's that About page. And Razor Pages uses this shared layout template. And if we come here to, if we come here to the weather forecast controller, this weather forecast is over here, this weather forecast controller. Well, how did we do this? Well, here in program.cs, we just kind of launch everything and bootstrap this startup. So back in startup.cs, we add controllers with views that gets us our home page. We also then down here say map controller route and give it the home controller in the index view so that we can go to just slash and it will get us to that home page. Well, how do we do our Razor Pages? Well, we say add Razor Pages. And then down here, we map Razor Pages. That gets us our Razor Pages. And now how do we do WebAPI? Well, when we're mapping controllers, we're also mapping this API controller. And that works out great. Now, if we were to create a template, it would ask us, do you want this or do you want that? And we've done all three. Now, the cool part of doing all three is that we can kind of see that just rigging things up here in startup.cs will get us whatever we need. Here we've got Swagger Gen that gives us that Swagger page and Swagger UI. And this is a great .NET 5 project. So let's upgrade it. Let's take a look at how we might upgrade it to .NET 8 or .NET 9. Well, I'm going to start off by just opening up the CS proj file. Now, I cheated. I don't have .NET 5 installed anymore because it's out of support. But let's upgrade this from .NET 6 to .NET 9. There. We just upgraded from .NET 6 to .NET 9. That was it. Yeah, we could definitely go into the properties page and we could pick it from a dropdown, but that's basically what it does, is upgrade this from .NET 6 to .NET 9. Next step, let's come in here and let's manage NuGet packages. And let's see if we've got any updates. Yep, it looks like we have some updates. And so let's update those NuGet packages. I accept. And now we've got this .NET 9 project. So let's start it up and make sure it still works. And now that we're rebuilding as a .NET 9 project, then we can see that we've still got WebAPI, we've still got MVC, we've still got Razor Pages. Here's our Razor page. Here's our MVC controller and view. Here's our WebAPI. We've got Swagger as well. Everything still works great. Now, what's really cool is they've done a lot of work inside of ASP.NET in both .NET 6 and .NET 8 and .NET 9 to make things significantly faster. So if you get nothing else out of this talk, just upgrading from .NET 5 to .NET 9 here will get you a faster website. upgrade your NuGet packages as well, and you can take advantage of the latest things that are available. That was really cool, really easy to upgrade from one to the other. Now, you may have dependencies that are tied to a particular version where you can't necessarily update until they update their dependencies, but for the most part, upgrading any project to .NET 9 is that easy. Just change the version and update NuGet packages, and it'll just work. So cool. Now let's take a look at any questions or thoughts or concerns about upgrading from .NET to .NET 9. So now let's take a look at some of the C# features that we can use as we get this project into kind of more of a modern feel. We'll look at file scope namespaces, we'll look at global usings, automatic global usings, top level statements, async main, minimal APIs, parameter and dependency injection, integration testing. Let's dig into all those. Let's first start with file scope namespaces. Okay, so I have this namespace, and then I have 4 spaces, and then I have this, my method definition, and then I have another 4. I'm 12 spaces in before I've said anything. Do we really need to indent that far? You know, I have a bigger font size on my monitor today, just so that we can see it, but it's like, that's kind of a lot of white space just to say, hey, you ready to begin? So let's do file scope namespaces. The old syntax still works, and this is great, but we can do this. You ready? I'm going to hit a single key inside of Visual Studio, the semicolon key. Now, I just unindented my class by 4 spaces. I now only indent 8 spaces to be able to get to the things that I want to do. Now, the old syntax still works great. I can use namespaces in the way that I always have, but in the majority of the cases, a namespace applies to the entire file, and I can just specify it once at the top of the file, and it will take effect for the rest of the file. If I have generated files where I need to be able to switch between different namespaces, I can still use the old syntax. But in places where I only have one namespace in the file, I can avoid that indent just by removing the curly braces and just adding a semicolon there. Cool. So let's run around and do that to all the places. I want one there. I want one there. Let's go to the code behind of our about Razor page and do it there. Here's program.cs, want to do it there. Here's startup.cs, and I want to do it there. Here's weather forecast, which is somehow not in a models folder, and I want to do it there. Cool. Let's look for namespace and make sure we got them all. Oh, we missed one. There's one. Cool. We got them. File scope namespaces. It's a great way to avoid excessive indents. Next thing, let's go back to our home controller. Here's a lot of stuff. We spend a lot of time fighting over, did we alphabetize these? Did we remove the unused ones? New people to C# are kind of like, why do I need to add one? These using statements kind of get in the way. Could we maybe move these to a central place? Because, you know, I'm going to use a lot of these in a lot of places. So let's do that. I'm going to create a new file, and I'm going to call this add new item global.cs. Now, there is no convention here. You might choose to call it using. You might put these at the top of one of your files, maybe program.cs. You can put this wherever you want. And instead of defining a class here, I'm going to go grab all of these using statements, and I'm going to say global space. Let's turn on regular expression. Cool. Now I have globally defined for this project that every file has access to system. Cool. Never in any of the other files do I need to say using system for this project. Now, if I have 3 or 5 projects, I'll need 3 or 5 global.cs files, But now I've just defined all of these usings in a central place, flipping back over to our home controller. Yeah, the home controller is just fine. All of the using statements work just great. So let's run around and go grab all of the using statements and set them into place here. I'll put these here, and I'll put these here, and I'll put these here, and I'll pin this so that I don't lose it, and I'll put these here, and let's go grab these using statements, and I'll move those here, and the using statements from here, I'll grab those and put them here, and we can go grab this one and this one. And now we have all of our using statements in one place. Cool. I'm going to go do that replacement again. Oh, now I have two globals in some places. That's okay. Let's come in here and select that one and 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 get rid of the extras. Cool. Now, I love this feature of Visual Studio where we can see duplicated lines, duplicated using statements. So with this green squiggly, I know all of these are represented previously in the file. I can delete those. We can remove these ones too. We can remove these. We can remove this one and these and these. All of those existed previously in the name. Cool. Now we have one file where in our code reviews, we can just kind of tidy up that one file and we don't need to fight about these using statements anymore. Did you forget to trim extra ones? Did you not alphabetize them? They all happen in one place and probably they're already all done. Now, if I'm just typing along, Copilot may go, oh, hey, you're about to use a thing and add a new using at the top here. So yes, I do need to move that into my global using file. I'll frequently go look for start of line using in all of the places and make sure that I got them all. Did I? Yep, I did. Excellent. So you may still have to move some into place, but now I've got one thing and we can see if we build and run it, it's still going to work just fine. Is this magic? Yeah, a little bit. It's a compiler trick. What it does under the hood is it just takes all of these and sticks them at the top of all the files as it compiles them. But like with these unused ones, it doesn't add any extra overhead. Now, if I have a very specific thing that I want to only define in one place, I may still do the usings there. Like sometimes if I'm using regular expressions or if I'm using a library, you know, who defines it, then I may only define that in that one file so that it doesn't apply to all the other ones and I don't get things. But I could also do my usings as with static things and do that globally as well, which can be really, really handy. Cool. So I've got these usings, and that's really interesting. But are there some that we can just kind of assume they exist? Well, yes. Let's open up our CS proj file again, and we can see that the SDK here is Microsoft Net SDK Web. So there's a bunch of usings that all web projects probably need to use. And so Microsoft could just say, well, these are just inherently there. So let's do that. I want to turn on GitHub Copilot knows where I'm going here too. I want to turn on implicit usings. Now, when I turn on implicit usings and I come back out here, we're still in the ASP.NET 5 folder because we've been upgrading it along the way. And then here's my obj folder. I'll come in here to debug.NET 9, and I have then this global usings.g.cs. It automatically generated this file and set it into my project to be compiled when I do everything. Ooh, global using global : This global colon colon, what does that mean different than just global? Well, what if I went in here to this home controller and I decided to call this, instead of site.controller, site.system? Well, what does system mean now? Is it the root project or is it the thing inside of site? And that's where this global syntax here, global colon colon, says, no, that really, this is the beginning of the thing. Okay, if I name this site.system, bad things will happen anyway, so don't do that. But that's where that global colon colon comes from. Okay, so this file is automatically generated. I'm definitely not going to modify it. But let's come back here into our global usings, and I'll just temporarily set this at the top. These are all the things that ASP.NET will define for me because I'm using a web project. If I was in a console project or a Windows Forms project, I would have different automatic usings here. But now I can see that I've got these duplicated. I can remove these. This one's already in place. I can remove all of these and this one. We now have 6 using statements in our entire project. That is really, really cool. And if we build this, we can see that it builds and runs just fine. Any thoughts or concerns about global usings or implicit usings? Cool. So now let's take a look at program.cs. Now, if I were to create a new project starting with .NET 6 and greater, we wouldn't have the separation between program and startup. So here in this program, we always, as programmers, look for static void main inside a program. That's like the thing that starts it up. Well, what's this doing? Create host builder. Okay, that's this method that's doing, well, I don't know. And then .build, .run. Like, what is it? What's even involved here? There's just a whole lot of stuff going on here. It all just feels like it's rigging up this startup.cs. Like, is it just a thing that gets this started? Let's see if we can use the new, simpler builder inside of ASP.NET. So I'm going to get rid of this create host builder. That thing's kind of silly. I'm going to then do this. Let's say var builder equals web application.create builder. We'll take in our input arguments so that we can use that to override any parameters that we need. And then let's say configure services. And then var app equals builder.build. And we'll configure the request pipeline and then app.run. Cool. Well, how do we configure services? Well, there's this cool configure services method here. Let's just call that. Okay. So let's go create one of these things. Let's say var startup equals new startup. And I need to pass it something. What do I pass it? I pass it a configuration, builder.configuration, and then configure services, startup.configure services. Let's pass in builder.services, configure the request pipeline, startup.configure. We need to pass in the app and the environment. So let's do that. Here's the app and the environment passed in. And hey, we've got a thing that now static void main kind of makes a lot of sense. That's cool. We need to set up our IOC container. We need to set up our request pipeline, and then we start it. Now, we could even take this a step further if we wanted to and get rid of this separation between startup and program. Now, if you like that separation, definitely stop here and just leave them separate. But let's actually take it a step farther. Here in this configure services, how about I just yank all of this part out and set it right here. Now we do need to change this. We could say var services equals builder.services, or we can just take it a step farther and say, nah, I'll just replace services with builder.services. Cool. Now let's do the configure method. Now this could get long. Nope, not there. There. This could get long because we're kind of building up things. So we might leverage extension methods in interesting places. There. And let's go grab this. Cut. And let's set that right here. And so we can see these extension methods that are already kind of hiding some of the interesting things. And oh, yeah, let's set that to app.environment. Now we've got that set correctly. And let's just remove use endpoints and use app directly to map our controllers. Cool. Now, public static void main makes a whole lot of sense. We're creating this builder, we're rigging up our IOC container, we're configuring the request pipeline, or we're building that into an application, we're configuring our request pipeline, we can see what's happening in development and in production, we can then rig up all of the middlewares that get run. This completely makes sense. And now we can remove startup completely. Let's just delete it. And we can now build and run this solution and it'll work just fine. Cool. Now that we've kind of moved from more of a legacy startup paradigm to kind of this newer, more modern startup paradigm, we can kind of get a better feel of how our application runs. And if we do like that separation between program and startup, we can definitely keep that and just call it. But we still get a simpler paradigm here. Well, let's take this a step further. Now, this only works in program.cs, but it's really cool. We have a class, we have a method, there's a whole lot of kind of stuff going on here that we may not need. Let's just delete it. Now, this is a cheater trick because it only works in program.cs, but it can automatically generate the class and method for us. This is cool. And yeah, we can build and run it and it will work just fine. Any thoughts or concerns on building all the things that we've done so far? Any concerns about upgrading from .NET 5 to .NET 9, using a new startup thing, file scope namespaces, global usings, implicit usings?
Did you say that, sorry, did you say that this will be starting on .NET 6 or later?
Yes, if you create a new project with .NET 6, you'll already get a program.cs that looks like this, but you can upgrade a previous project to .NET 9 in the way that we just did, kind of walking through these steps.
Yeah, I was just curious where it started to work this way. Because it wasn't on 9,
.NET
it
6
was
is
earlier.
where it began.
No, that's it. Thank you so much.
Yeah, great question. Now, this is a talk about minimal APIs, but we haven't done minimal APIs yet. Let's add some minimal API stuff to this. app.map get, and slash is taken by our home controller. So let's say, I don't know, API. And I'm going to say this API is going to be, we said string name return new message, hello name world, and we've got this coming from the query string. There, we've got a minimal API. Now, the cool part is that this minimal API can play alongside Razor pages and controllers and views and WebAPI. It's just another paradigm for building this. So we've got that get in place. Let's say app.map_post. Now, one of the things that we like doing inside of this is we might say, let's say minimal 1, 2. Oh, actually, this was /API/minimal. There we go. And let's make these parameters 1 and 2. We do attribute routing today, and so this is a similar thing. We can say int 1, string 2, and then we can return a new message equals 2 and ID equals 1. And that is a post, but with attribute routing. That's pretty. Oh, let's also take in an object body. We'll map that JSON into place, and we can say data equals body. Cool. Now we can then add this from body, and that's a great way to be able to identify, hey, this is the JSON body of that post, or maybe it's a form post, and it'll automatically serialize that into the object. Similar to this one, we could say from query, but it isn't necessary. Cool. So now let's do something a little bit more substantial. Let's say map put. Now here I'm going to say API minimal. And I want to now take in a object body. Let's call this from body. And what am I going to do? Well, now I've got some curly braces so I can do more stuff. Let's say if invalid, bool valid equals true in this case. If not valid, I want to return bad request, message invalid data. And then I'll save to database and I'll return OK. Here's data saved. ID equals, I don't know, let's just call this 7, and data equals body. Cool. Now there's a little mess here. We've got bad request, we've got OK. Now, when I'm in a home controller, that makes sense. Here's view. When I'm in a web API controller, that makes sense. I can say return this or return JSON. But, you know, what is this? What is OK? What is bad request? Well, it's based on this controller base. But what is this over here? Like, I want to say this dot bad request, this dot okay, but what is this? Well, this is this Lambda method. And this Lambda method doesn't have a bad request or an okay to it. Well, we have results. Now what results does, which is pretty cool, let's go to definition of results and take a look at what this thing is. This is a static class that just defines all of these iResult things. In MVC, we have iActionResult. Here in WebAPI, we have iResult, which is pretty much the same. Bad request, conflict, challenge, created at route, JSON, no content, okay, problem, sign in, sign out. You know, all of the statuses that we were looking for, here's not found, they're all here inside request, result rather. And if we go to definition of iResult, it's just a thing that implements this execute async, much like we've done with MVC and Web API. We can just put in whatever logic we want. And so I will frequently build an iResult, a JSON result, that allows me to both set the status code and the body, which, by the way, these methods don't. So it's really easy to override that. So let's say instead of this, results.ok, results.bad request, and now we have a minimal API that is able to do more stuff. We can return 200, we can return 404, 401, any of the things that we want to do. And we can also say just results.status, and we can return, I don't know, 418, which I really like that one. HTTP status code 418 is I am a teapot. It started out as a joke and it got put in the spec. It's awesome. Cool. So now we've got some minimal APIs. Now, if we fire up this web app, we can see that we've still got our web API, we've still got our MVC, we've still got our Razor pages, but now we have this fourth paradigm, which is minimal API. So here's our MVC, here's our Razor pages, here's our weather forecast, our web API, and we can also go to API minimal, and there's our thing, hello world. Let's pass in a query string, name equals slc.net, and we can see that it's automatically parsing JSON and doing all the things. We now have 4 paradigms to be able to render the content in really interesting ways. Cool. Well, that was fun to kind of get that into place. Let's take a look at how we might test this app. So I'm going to close this project, close solution, and I will open up the chapter 9 testing. Just that'll save us some. Chapter 9. There we go. Open a project. Okay, fine. Let's do this the hard way. Minimal APIs, source 9, testing. Cool. This will just save us some typing as we get into our testing. So let's take a look at this unit test. Now this unit test, we just want to create a new weather forecast. So I can say var controller equals new weather forecast controller, and away we go. Except for this weather forecast controller needs a parameter. Now this parameter is that logger. Well, how do we create the logger? Well, we could say, I don't know, let me create public class my logger, implements I logger of t, and then start implementing all the methods. And it's like, I don't really want to do all that work for the sole purpose of just kind of, let's not. Instead, let's look to a mocking library. And we can use, in this case, and substitute to be able to create for ourselves an automatic mechanism for doing this. So here we're going to say substitute for an iLogger of weather forecast, and it will just build us this logger. We can then pass that into creating the new weather forecast controller, and away we go. But let's imagine a world where we also want to take in, I don't know, an iFoo. And now if I come back to my website, my test, then we'll see that this test is failing, not because I changed anything, but because it now needs another dependency. So now I would need a iFoo, and so I would need to create another var foo, substitute for I, that's kind of a lot. Here in ASP.NET, we have this automatic dependency injection thing. Let's do a similar thing here in our unit tests. So instead of doing this, let's say I would like to use here auto fixture to be able to create an IOC container for my tests. So I'm going to create this IOC container that rigs itself to end substitute. And then I'll just say, hey, go create me this. Oh, I guess I don't need to create. Go build me this. Oh, I know why I did that. go create me this weather forecast controller. Well, there is a bug inside of AutoFixture that it doesn't really know how to create controllers. So we actually have to say .build emit auto properties .create, and that will create me my controller. Cool. Now that I have my controller, now I can just call that method on the controller. Well, that method is just, it goes and gets 5 random things. Now, I don't know what random.next will give me, so I can't validate what temperatures they are, but I know that there should be 5. Cool. So we've got these 5 and away we go. Well, we want to be able to do this inside of, I probably need to remove my IFU. We want to be able to do this inside of integration tests too. So let's create this fixture. Now this fixture descends from Web Application Factory of type program. Here's our program here. And yeah, we create this web application thing here. So here in this fixture, we'll just build this Web Application Factory of type program. We might choose to override dependencies if we want. And then in our test, let's say weather integration test, I want to go create an instance of that. And then let's use that to create a client. Now, this is just an HTTP client, the way we've done HTTP clients forever. And so we can just use this HTTP client to then make requests. Let's just call /API/weather forecast. Now I'm getting back a response. I can read the body as a string. I like deserializing it myself. I could also say get as JSON. Get JSON async of type list weather forecast. But I kind of like that I'm taking a little bit more control. I have the request, I have the response code. I can just kind of take a look at those pieces. And so I actually like this. Get async. I like deserializing it myself. I know I've got weather forecasts, and so that shouldn't be null, and I should have 5 in there. And so now I can do this integration test of ASP.NET launching the website. Now it does it in memory. It doesn't actually look for a free port, but I don't have to worry about what port number it is. Did it launch? Do I have to kill it? I just go create an instance of this, create an HTTP client that's connected to it, and then use HTTP client the way I always do. That's really cool. So let's do that integration test with our minimal API. Well, I have this minimal API integration test. I create a new fixture. I go call /API/minimal. I pass a name of test. And so I think that my message should be hello test. Oh, last time I named it 3 instead of 7. I can also do a test for a post where I'm posting content in and validating that it gets that back out. I'll leave the put test to the reader's imagination. But each of these tests then allows me to be able to flex this minimal API, this integration, without having to worry about ports and available ports and 3 things. So let's go build and run these tests. Well, the problem here is that program is inaccessible due to its protection level. I want to create a web application factory of program, my program here, but so I'll just come up here to the private class and make that a public class. But I don't have a class definition up here. We use that magic thing. So how do I do that? Well, what's interesting is what it auto-generates is a private class, but it generates it as a private partial class. Well, that's easy enough. Let's implement the other side of that. Public partial class program. That is such a hack. That is ugly. It's like, why would we ever do this? This is so nasty. Yes, I agree. So I'm going to add a comment that says public for testing, and that kind of defines why I've done. I just implemented the other half of this partial class and marked it as public. So now because I did that, now we can build it. Everything works just fine. And we can now come in here and run our unit tests and our integration tests. And we'll see that we now have a passing unit test. We also have 2 passing integration tests. Well, actually, 3 passing integration tests. All of our services work, and that test ran really fast because we didn't have to spin up a thing. It all did it in memory. It was amazing. Testing with ASP.NET is now just really, really cool. This fixture, I'll pull it up in the source code here. This fixture is really cool. We just build this that descends from your program, and we can override any services that we need to, and it just makes testing really, really fun. Any questions on testing inside of ASP.NET? How does that test work with a secure endpoint? Good call. There's 2 ways that we might do a secure endpoint. The first is that we might connect over HTTPS. And the cool part, because this spins it up in memory instead of spinning it up on an actual port, then there is no HTTPS. The cool part about this app, though, is it's running the entire set of middlewares. So, for example, if we have use authorization and we need to then do authorization in here, then we can hit that authorization piece right away. Now, we may need to use dev jots, and so we have some mechanism. No, not that. There we go. In this .NET Global tool, we can create development jots that are that can authenticate into our services to be able to do these authenticated secure tests, even if we're not actually connecting to Okta or to Google Authentication. We can still do these authenticated tests through our ASP.NET. Great question, Jim. That was a lot of fun. Any other thoughts or concerns right here? Mock it!
When should
Cool.
we
So-
be question?
Go ahead.
Yeah. When should we be using minimal APIs over regular controllers?
Ooh, good call. Let's dig into exactly that right now. I have here the 3 methods. I probably also need an app.delete, a map delete, and API minimal ID that will do interesting things. And so this is for one entity. Well, what if I have, I don't know, 5 or 6 or 8 entities in my app? This program.cs is going to get like this big. That's how do we kind of contain this? Well, let's refactor this a little bit. I'm going to say here, let's create a folder. I just happen to name it APIs. Let's add a new file in here, and let's call this minimal.cs. Oh, it already contains one? Oh, there we go. Minimal.cs. I'm going to say public class minimal. And let's say public void init. And let's comment, let's put these in place right there. And so I'm going to maybe, I don't know, let's extract this, and I'm going to say public void map get. And so that's no longer a lambda, but it doesn't return a void. It returns a, oh, we probably need a new class here. Let's create a model for this. Let's call this a add new item, minimal model, and file scope namespaces for the win. Public int ID, public string message. Well, actually, let's make it required. And public minimal model data. We'll make that one optional though. And now we've got, oh, question mark in the wrong place. There we go. Now we've got a model. So let's come back here to this one, and let's say it returns a minimal model. So now we've got that minimal model. It's still doing, oh, yeah, there we go. It's still doing all of the things that that method needs to do, and that looks great. Public minimal model map post. Let's go grab the post method there and set that in place. Public result map put, and we'll go grab the put method here. It's no longer lambda. Oh, yeah, let's return a new minimal model and ID and data. And here's our map put. That looks good. And public result map delete. Let's go grab our delete method. Set that right here. Oh, this is a new minimal model. And so is this one. ID equals ID. Oh, that's an I result. Let's return a minimal model there. Data equals body. Oh, hey, we can use a strongly typed here too. Let's take in a minimal model there and a minimal model there. Cool. Now we've kind of got a class that does all these things. So let's rig this up. Now we can take in a thing that we built right here. We built a web application. So let's take in this web application app, and let's rig up some stuff. Well, we can rig up map get to map get, and we can rig up map post to map post, and we can rig up map put to map put, and map delete to map delete. And now back in our main program, let's now use this. Okay, so we want to say app dot get required, or app dot services dot get required service of type minimal dot init app. Cool. I love that one liner so that we don't hit merge conflicts. And now my app won't be too long. If we have lots of models, then we can go grab this. We'll say this one is a user and this one is a order. And we can rig all those up. Cool. This will build and run just fine too. But what is this? Now, as I look at this, what does this look like? Well, it looks a lot like a controller. Exactly, Jim. This controller is, well, a controller. I would have a whole lot more success by going controller base and adding the API controller attribute on there and just getting rid of this whole thing. This is a HTTP GET. This is a HTTP post. This is a HTTP put. This is a HTTP delete. Thank you, GitHub Copilot. This is the controller. Why don't I just build a controller? Controllers are not obsolete. Controllers are great for doing exactly that. When I have a system that has, I don't know, half a dozen models where I have 4 methods for each, then controllers is the right solution for this. Minimal APIs make no sense in that type of project. Well, what is then the right size for a minimal API project? Well, let's close this solution and let's open up this solution, this right size project. Now, for this project, my goal is to just have this little thing that exposes a JSON file. Or maybe I'm accepting a form post and I'm going to send an email. Or maybe I just need some middleware to transform data from and to. And that's where typically I would go reach for Node, but we can now do it inside of ASP.NET as well. So I have this interesting config file, and my task today is to just make this available on an HTTP endpoint. That's what I want to do. So in this project, we have one CS file. That's it, one C# file. We have an app settings file, a launch settings file, just kind of the configuration details of ASP.NET if we want them. But let's take a look at this program.cs. So we create our builder. We'll add in Swagger gen, health checks. Let's go read this interesting config. We'll deserialize it into this strongly typed interesting config class. Here's that interesting config class. And then we'll add it to our IOC container. I put these curly braces in here just so that I don't cheat and reach into this JSON file directly, but rather I'll use my dependency injection to be able to get at it. So then down here, I have this spot where it just takes it that interesting config, and we could say from services, if we really wanted to, from service, to be able to identify where it came from. But by default, it will just go grab it out of the IOC container because that makes sense. And it will just expose that. So let's start up this minimal API. Now, if I want to start this minimal API, I can then come to this home page, and I can just try it out. And yep, there's my minimal API that is able to expose that data. Now, to make a good API, I probably want some Swagger details here. So let's add some Swagger and Swagger UI. I will also go add Swagger gen here, the endpoints API Explorer. So it'll go infer my endpoints and put them in Swagger. So let's go to that page, the Swagger page. And now we can see, oh, it found my API endpoint. Excellent. Let's try it out. And we can see that we get that JSON file back. Now, if we have an API, we probably want a little bit more best practices around here. So we probably want to say, not a valid page should return a 404. Yes, it does. If we open up Google Developer Tools, we can see that, yes, that is indeed a status 404. How did we do that? Well, down here we say, let's go map everything else to this not found page. Now, when I first built this, I did it like this, and I kept getting Chrome's you didn't connect successfully page. And I'm like, wait, is my API down? So I actually returned some JSON so that I know that that's what I did. Another thing that we might want in an API is we want error handling. So if we get an error, we've automatically rigged up here to go hit our error page. And so we'll just map error to return 500. Perfect. Here's our 500 page, and it doesn't tell us anything more about it, just says it's a 500, and that's mapped really nicely too. We might also want a health check page. So here's our health check page that Kubernetes can hit inside of our Docker container. Oh, that's not it. Spelling is hard. Heath. Health. Here's our health check page that allows us to be able to validate that our system is healthy. Now, we do want to check for both a 200 and the word healthy, because if we are unhealthy, healthy is part of the word unhealthy. So we might want to take more control over this and return JSON, for example. But we have all of that here. Here's our health check page, and we've got the health checks built in. And so here we have a complete API with doing our task, not found pages, error handling pages, health checks, all in 46 lines, including this hack for testing. This is the right size for a minimal API. If you have a whole bunch of entities, then use controllers. If you have a server rendered site, then use MVC. If you have more of a static site, more of a web WordPress-like thing, then use Razor Pages. But if you have that need where you just need a little bit more, just a little API, then use Razor Pages. Use minimal APIs. And if you want even less than that, then Azure Functions is right there. Azure Functions is kind of the lightest weight piece. WebAPI is kind of a heavyweight, more feature-rich piece for this. And minimal APIs fits right in between. We now have a fourth paradigm inside of ASP.NET that allows us to build these really, really small things. That was a great question. Just need some logging, yes. So the cool part is all of the things that we just live coded are all in here. We started here and then we did this and this. And so you can start at any place and continue on, or take a look at the solution at that spot. The code is up online right now at github.com/robrich/minimal-apis ASP.NET. And you can find me on Mastodon, robrich@hashiderm.io, or hit me up on any of the other socials here on robrich.org, and I would love to take it further. For those of you watching online, hit me up on any of those places. For those of us who are here live, what do you think? What questions do you have? Where would you like to take this further?
Okay, I got a question, Rob.
Let's do it.
So I haven't tried to keep fully up to speed with ASP.NET. I know earlier, so I want you to keep me honest here, but I know earlier, as in like .NET 6 days, .NET 7 days, when you introduced the controllers and MVC and other things like that, there were so many different additional registrations, attribute filters, you name it, that happened behind the scenes that it caused, I don't want to say caused, that it introduced a lot of performance difference compared to the raw minimal APIs that you presented here tonight. Is that still the case, where if you really want something high performance, you might want to consider going with minimal APIs just for the performance advantages?
Maybe, although I generally wouldn't pick minimal APIs for performance benefits. I would probably pick it for ease of use. What they did that was really cool is they kind of picked up the MVC stack and they put minimal APIs in the middle and put MVC back on top. And so all of the things that we have with MVC, attribute routing and validation and those types of things still are there inside of minimal API. We still have all of the request pipeline, authorization filters, and so you can choose to turn those on and off based on how you configure how you configure your minimal API. So here inside of startup.cs, I can say, well, I don't need authorization, so I'm just going to remove that middleware. Or I don't need static files, I'm going to remove that one. I don't need HTTPS redirection. And so we can get performance gains just by removing some of those middlewares that we don't need. But the other thing that they've done inside of .NET 6, .NET 8, .NET 9 is start using span-of-T a whole lot more. And span-of-T just makes the website faster. So I've never had any performance concerns with ASP.NET, minimal APIs or otherwise. It's just really fast. If you're hitting performance gains, performance concerns, there are definitely ways to tweak it, but probably The thing that's spending the majority of the time in my ASP.NET web app is waiting for the database to return the results. And so look at your database query, not so much your ASP.NET runtime.
Yes, you'd have to have a very high performance situation for that to be a concern.
Yeah.
So very good point. Thank you.
And if you're at that high performance thing, you might be looking at Go instead, because that's kind of where Go really excels, is in the performance category.
Yep. Looks like we have a hand up.
Hey there.
Jim.
It seems like we used to be a lot more piecemeal when it came to .NET, and it seems like with the new ASP.NET Core, it seems like a lot of times it's like you have to add your little pieces as you go, right? Middleware seems to be a lot bigger thing when it comes to ASP.NET Core. Can you speak to how like you can't just necessarily fire up a .NET thing without having to fire up a lot more middleware kind of stuff? Can you speak to that, like with like I don't know, with middleware? It seems like middleware is a bigger deal,
Yeah.
right?
Well, what's cool is in the ASP.NET Classic days, is that a thing? .NET Framework, all of these middlewares existed. They were just kind of hidden from us. And so the cool part is they're now showing us the pieces so that we can choose to turn them on and off. Middleware in Node is a definite thing, and so you can choose to add or remove those. And here inside of ASP.NET Core, you can choose that as well. If you want to kind of take a lower configuration approach, that's when .NET Aspire looks really cool. And .NET Aspire allows us to be able to kind of have automagic configuration stuff happening in a really cool way. .NET Aspire leverages OpenTelemetry and some really cool deployment stuff with containers. It's kind of the next evolution of Project Thai. And yeah, it kind of makes all of that middleware-y kind of stuff just melt away. It's really cool.
That's awesome. Thank you. Appreciate it.
Yeah. I actually really enjoy that they kind of expose the internals here. You know, for a while I'm like, but what are you doing? And they've now said, well, it's right here. Well, awesome. This was a lot of fun. If you're watching this later, hit me up on robrich.org and let's continue the conversation.